Hello, welcome to my channel. You can find the worksheet below this video. Let's start our lesson. Okay, today we start our number lesson 3, rational numbers and irrational numbers. Today we will discuss 3 parts: decimals, rational and irrational numbers, and how to convert a repeating decimal to a fraction. So first, let's clarify some definitions of decimals. And for decimals, we have 4 parts: and repeating decimals, non-repeating decimals, terminating decimals, and non-terminating decimals. And the first one, repeating decimals. Decimals which have a recurring pattern of digits. And in this part, the important part is recurring pattern. And for this part, I will give you 2 examples. The first one, we have 0.33333, and it's infinity. And in this way, the recurring pattern is 3. And so this is a repeating decimal. As in some textbook, you may see in this way. And 0.3 and with a bar above 3, and this bar means repeating. Okay, and the other example I can give you is 0.181818, and so this means repeating pattern. Okay, and so in the textbook, and it may be shown in this way. There's a bar above the repeating, sometimes repeating group. Okay, so sometimes it's over the repeating digit, sometimes the bar is over the repeating group of digits. So this is repeating decimals. The second one, non-repeating decimals. Decimals which have no recurring pattern of digits. And this one, no recurring pattern, and I can give you one is like 2.828427225 and So this is equals to square root 8. So this is non-repeating decimals. And the other one is, for example, like square root 2 equals to 1.41421 So this is non-repeating. So because there's no recurring pattern, and maybe you see, okay, this is 1414, this is repeating, but and then change to 21, and even for this one 2828, and then change to 42725. So this is no recurring pattern. Okay, and the next one is terminating decimals, and the decimals with affinity number of digits. And this one is very easy. Terminating is, we can count because this is limit finite number. So such as 0.4 or maybe 0.125. So these are terminating decimals. And the non-terminating decimals with an infinite number of digits. And in this way, the repeating decimals, all of them are non-terminating decimal because they keep repeating. Like 0.3 is repeating, or like the square root of 8 equals to 2.828422725, and So this is an infinity number of digits. So this is non-terminate decimals. And after we review about the decimals, let's move to the rational and the irrational numbers. And the rational numbers, decimal number which repeat or terminate, can be converted into a fraction. So this one, the important part is repeat, terminate, or. So both of them can be converted into a fraction. For example, we have the 0.3 with repeating, and this one equals to 1/3. And later, this is a repeating decimals, and later I will show you how to change the repeating decimals to a fraction. And another example is 0.18 with repeating, and this one is 2/11. And the other one is terminate. 0.4 equals to 2 over 5, or 0.125, this is equals to 1/8. Next one is irrational numbers, decimal number which are both non-repeating and non-terminating, can't be converted into a fraction. For example, like root square 8. So the first one is non-repeating, 28, 28, 4, 27, 25. There's no recurring pattern, and then non-terminating. So this is an infinity number of digits, and another one is 0.2, and so this one the same, and we have non-recurring pattern and non-terminating. So these two are irrational numbers. Okay, so this part converting repeating decimals to a fraction. And now I will use an example to explain this one step by step. The first one we can use 0.3 with repeating, and for this word, how to change this one into a fraction. We know the answer is 1/3. Okay, and the first one is set x to be the fraction. So this one, x is the fraction, so x equals to 0.3 with repeating. So we can write this equation. Next one, identify the repeating digit or digits. For this one, there's only one digit is repeating, so it's 3. And multiply both sides of equation by a power of 10, which move the repeating part to the left of the decimal point. So we need to times a power of 10, we move this 3 repeating part to the left of decimal. So this one we can just use 10. So we 10x equals to 3.3 repeating, because we just time 10. Okay, and if necessary, if needed, okay, write another equation and multiply both sides of equation by a power of 10, which move the repeating part to the right of the decimal point. If we notice this one and the repeating part is already at the right of the decimal, so we don't need a new equation. So now we have this one, equation 1, equation 2, and subtract the equation and solve for x. So we have 2 subscribe 1, and this one is 10x minus x equals to 3.3 with repeating minus 0.3 repeating. For this step, we want to remove this repeating part. So we got 9x equals to 3 and x equals to 1/3. Okay, so now let's do 2 more examples. The other examples is 0.18 with repeating. The first things we need to do is we need to set x as the fraction. So x equals to 0.8. So this is the equation 1. Okay, and then we need to identify the repeating digit. So repeating digit, now we have 2, so it's repeating digits. So the repeating digits, repeating 1/8. Now you need to know, and we need to multiply both sides of the equation by a power of 10, which move the repeating part to the left of decimal. For this one, we need to times 100. So it's 100 x equals to 18.18 repeating now we have equation 2. And the fourth step, we need to multiply both sides of equation by a power of 10, and which move the repeating part to the right of the decimal, and it's already there. Because this one we need to subtract and remove the repeating part. So step 5, use equation 2 minus equation 1. This one we can got 99x equals to 80. So it's equals to 99, 80, 11. So it's 11, 2. Okay. So now I will give you a hard one. So this one is 0.94. Okay. And so this one we set x as the equation. So x equals to 0.94 with repeating. And then we need to identify the repeating digit. And so this is not 94 repeating, this is only 4. So we have the repeating digit is only 4. So now we need to move this repeating part to the right of the digit of the decimal point. So we need to times 100. So in this way, you can see this is for repeating and this is for repeating. So if you want to write in this way, it's okay. If you don't, you can just write in this way. Both okay. And then now, the interesting part, because the first two examples, the repeating part already and the part of right of decimal, but this one is not. This one we need to times 10. And then to make the repeating part to the right of the decimal point. And then we have equation 1, equation 2. So 1 minus 2, and then we can remove the repeating part. So this is 90x equals to 85, and x equals to 85 over 90, and then we can simplify this fraction, and we can just divide 5 for each, and then x equals to 17 over 18. Okay, so this is today's class. Thank you for watching. If you like my teaching, please click the subscribe button. Please let me know your questions in comments.